Hi, welcome to Make or Repair. I've just finished repairing and generally refurbishing this Atari 2600 games console. I think this model is nicknamed Woody for obvious reasons. Anyway, I'm going to show you what I've been up to. I've got this old Atari on my desk today. This is a family member's. I'm not sure what to make of this. May be working, may not be. Whatever, it's going to present a problem. It is hardwired for an old analog television. And looking cosmetically, I mean, okay, it's a bit dusty and what have you, but fairly good, except for this button here that's broken off. So that is certainly going to be a challenge. I have no idea where I would find another button. So this seems to be fairly complete, except for one important thing that's missing, which is the power supply. So we've got joysticks, 2 of them. We've got 2 paddles, so that looks about right. We've got 3 games over here, or 3 cartridges, but I'm not sure that we've necessarily got everything that we've got leaflets for. So I suspect there may be a few more bits and pieces kicking around in someone's attic. It just says power adapter, no sign of voltage or anything like that. So I shall have to do a little research. I'm taking this apart before I power it because I want to look at the capacitors, perhaps replace a few, just to avoid them failing spectacularly and causing a bit more trouble. Inside we've got not a great deal to see. We've mainly got a bunch of RF shielding here, and we've actually got some tuning available through the top. We might have to just take this apart a little bit further in order to gain access. Here's our modulator though. For power we've got this guy here. So our power comes onto the board, but just over here with this heatsink we've got an LM340T5, which is a 7805 regulator basically, nothing special about that. It's just pasted onto that piece of aluminium, or steel possibly, given how rusty it is. And we've got one electrolytic capacitor up here and one down here. Both axial, of course, as was the way in those days. That's 4.7 microfarads, 2200 microfarads, 16 volts, which kind of holds with the 9 volts input. And also 9 volts input with this 7805. We've clearly lost a few of these little things to make it look pretty, but they're just black felt or black rubbery felt, so we can probably just put something together if we need to. See if we can't separate this from the case. Single-sided PCB, of course. So I don't know if this has ever been repaired, but certainly there's a bit of flux around on 1 or 2 of the junctions. Weirdly, this modulator is sitting on a board which is then pinned through. I mean, what's going on there? Presumably it's meant to take a specific modulator and they've just altered it for different countries. So let's take off this RF shielding, and this should reveal our MOS processor and a few other bits and pieces. So keep in mind that nearly all of this box, 2/3 of this box, is just to make it look big. It actually physically is this big. That is all of the electronics really, apart from the modulator and a little bit of switching really. So there's really not very much to this. The ICs are all proprietary code, so the best thing I thought was to link in this site, which is atarihq.com. It has a handy list. Count them, 1, 2, 3, 4 ICs. Okay, so a quick run through. The processor in the middle, the little one, is the 6507, largely the same as the more common 6502. On the left is a 6532 Riot, which stands for RAM, I/O and Timer. This particular one has 128 whole bytes of RAM and a couple of I/O ports, obviously connected to the joysticks, and of course a timer. On the right is a PAL TV interface adapter, and in this case it's the one codenamed Paula. Well, I'm not unhappy with that. That is reading 2.19 millifarads or 2190 microfarads, which is pretty much bang on, and 90 milliohms of series resistance. So yeah, I'm kind of hopeful. So down here we've got a 4.7. Oh, that looks very poorly. So I think before I power this up, I'm going to whip that out and see if we can't do something. Alright, now that's disconnected, I will just re-measure the capacitor again. Yeah, it's better, but not where it should be. All right, let's see what I've got in stock. Probably not an axial. 4.7 microfarad, 35 volt. This will do us 4.7 microfarad, 50 volts. I'm ultimately going to replace all 3 electrolytic capacitors, but I don't have them in stock in axial, and I like to keep the original look. So the 4.7 microfarads are both reading bad, so I've got to replace them. Then I can power on the unit for testing and figure out any further repair while I'm waiting for the parts to arrive. And yeah, I'm using the original style of solder, which is leaded in this case. I always use whatever the manufacturer has used. Let's get a bit of power to the thing then. Alright, we are set up to have a quick look. So I'm trying to leave this particular capacitor. And what I'm going to do is I'm going to wind the voltage up a little bit, just to let that charge a bit more slowly. Drawing 290 milliamps, which feels like it should be okay. Now I'm actually slightly low power. It probably might be just about regulating 7.2 volts. And there's my voltage on there, so that's all right. Let's see what we've got coming out of 7805. There's our basic 5 volts, give or take. I'll wind this up to 9. Yeah, that's fine. Let's take a look at this regulated output now then. 5.128 volts, so that's sort of all right. Okay, well of course one of the hardest things to deal with one of these is the fact that you need an old analog television, and I just happen to keep one for just such testing. And so I've loaded up Space Invaders, and as we can see, it kind of works. I forgot how slow these games were, weren't they? So the big question is what to do with this. Obviously we can see on the TV behind us that it is actually working, but of course not everyone has one of these televisions kicking around just for the purpose of playing old games. There's 2 possibilities. One is to sell it as is and perhaps just get a power supply sorted out for it. But a collector who wants as is will obviously want this button replacing with a proper one. So that's challenge number 1, because irrespective, I mean you can operate that with a screwdriver, but irrespective that button needs some sort of repair. I've had a search around, I can't seem to find one, so that's a bit of a problem. I could file off the top of this where it's all rough and attach something, drill it through with some metal pin and attach a new actuator to the top with epoxy resin, and that will be a good workaround, make it functional at least, but probably I'd have difficulty getting it to match the other ones. I mean these need cleaning, that's easy enough. But yeah, these are plastic with an aluminium sheath over them. The next one of course is the UHF. Well, we can take this modulator out and we can replace this with a little mod. I mean it'll only be a transistor and a couple of resistors I should think, and that'll give us a video output and audio output separate lines, and that'll feed into most TVs. Even nowadays a lot of televisions will still take something of that nature. If we have a little look elsewhere, what else might we have to do? Power supply of course. So I'll have to talk to the owners, see what they want to do, and see what the resale value is with 3 games and a few bits and pieces, and indeed actually whether they've got any of the other stuff up in their attic. So I've talked to the owner, we've decided what to do with this, which is basically to prepare it for resale. So I'm going to complete the recapping of this. So I only see really 2 other electrolytic capacitors. Obviously I've got to clean out the case. Do we put the mod in for the AV? No, not in this instance. It seems that these sell perfectly well without doing that. Now the mod isn't expensive, 2 or 3 resistors depending what you want to do, and a transistor and a few pieces removed from this main board here. Some parts have arrived, so I can carry on now with this Atari. So previously I put in a few temporary capacitors just to make sure I could check that this thing was working without doing any damage. But I didn't have the proper axial capacitors, so I've got those now, so I'm going to swap those out. So that's one job, and obviously there's a bit of residue on the board that I'd quite like to clean up. A bit of a tidy up would be nice, and obviously tidy up these connections and spray a bit of cleaner into these switches and work them backwards and forwards a few times. Some people replace these. I've inspected those. I see no cracks in the material, and so I don't think I'm going to be replacing them. I don't see any point at all. And that brings us to this rather annoying switch. So here's a good switch, well, goodish switch. We can see what it looks like. It's basically a plastic actuator with aluminium sleeve on it that's sort of got a texture rings ground into it. So I have looked for cheap enough spares, donor boards, etc., that I could use for that, and I'm not coming up with one. So I need to tackle the original and get it into some sort of acceptable shape. So what I've decided to do is I'm going to file off that break point. So I'll file it off, drill a hole, and then machine a piece of aluminium to be very similar. So apparently I need 5.85 for the outside diameter, 23.25 length, these are 1mm, a 6mm stub, and I can make that about 3 wide. That'll be in all aluminium, of course. I need to find a way to try and texture this, and I'll put some little grooves in the end here. Now I also need some of these little rings, but I can soon make those. I have a material that's very, very similar to this, so I can just punch those out. That's easy. I also need to try and measure what this grooving is so I can kind of try and match it up. I can capture still on that, just so I can measure it more easily. So I'll make that 4 rings per millimetre. I'm just turning it down to size and a little bit long. Now I've got to put in grooves. I'm using a cut or a ground for some pulley that I made previously. So I'm advancing it along 0.25mm, cutting 0.3mm deep, then withdrawing the blade, advancing it 0.25mm again, and repeating about 100 times. Feels pretty good. Feels the same as the one on the Atari, so pretty happy with that. I'm just going to chamfer off this corner and then put the same texture on the end here, and then I'll cut this off, turn it around in the lathe and form this end. So it's a lovely day outside, so I've set up my anodising stuff out here. So down here we've got a power supply. That's a constant current source. It's set for 20 milliamps in this case. So you want about 30 milliamps per square inch, something in that region. I'm a bit below that, but then again I've got textures and things like that, so I'm going for 20. In the background we've got a number of chemicals, each set in their respective glass beaker. On the left hand one here we've got an alkaline cleaner, then we've got an acid pickle, and then we've got an empty one ready for sulfuric acid. So that orange container is 40% sulfuric acid, battery acid, and I'll be mixing that with an equal amount of water, so it'll become 20%. Just here, for example, I've got a big tub of water. Here I've got a tub for getting distilled water when I'm rinsing things. And over on the far right, I've got some distilled water to wash things off with, and behind it there's a tub with sodium carbonate in it, just in case I need to neutralise anything. So I need to put my goggles on, I need to put something on to cover my sleeves, and also some hand cover, and then I'll mix up that sulfuric acid and we'll give it a go. I'm only going to cover the anodising process briefly here, but basically I'm just mixing up my sulfuric acid. It will warm up just a shade as I put this in, but you know, it'll hang around about 20. I'm doing a roughly 50-50 mix. I'm using an aluminium strip hung over the back of this. Some people say you have to use lead, but industry indicates aluminium and stainless steel are both fine. Here is my anode, which is my piece I'm going to anodise, and it's on a piece of titanium wire hooked so that I can just kind of hook it over the side. But first it's going in the cleaning solutions. These are actually quite warm. You'll find plenty of recipes online for that, and it is bubbling slightly. And then we'll do the next one, and then it will go in the acid after that. We rinse between each, of course. Okay, so just hooking the anode, which is the piece of work, over the end and attaching the positive. Just want to make sure that the two electrodes cannot possibly touch each other. The negative goes onto the cathode at the back of the beaker here. And yeah, we turn the power on and start it going. And it's going to take about 45 minutes, unfortunately. During that time, just stir it occasionally, agitate it a little bit, and monitor the temperature. The temperature needs to stay at about 20 degrees centigrade. And if you're doing big pieces, then you might find the temperature rises. This one's staying perfectly stable at about 20 C. But if it does start rising, you can always stand it in a bowl and introduce cold water and a bit of ice and things like that around it to keep the temperature down. So first thing, power off. Now I can fish out the part, I'll give it a quick rinse in the tap water tub, and then some further rinsing and some more rinsing, and then I'll also give it a quick dip in the sodium carbonate just to neutralise anything that happens to be left in the grooves. Another rinse after that. Then it'll be ready to boil in order to seal the anodising, which can be a bit soft if it's when it comes out of the acid. So I've just scored the inside, used a little bit of epoxy and pushed it in, and there it is. Looks like a new one. 3 capacitors I need to change. Let's get those changed, and then this is ready for reassembly. I have cleaned the board, just gone around all the big obvious traces of flux that are on this board and on this board, so it looks a lot better. There's a few places I can't really get to around the switches and things, but 2200, hopefully that'll fit. 25 volts. A couple of 4.763 volts, which is ridiculously over-spec'd for this, but you know, who cares. The hole's open. Some very nicely marked plus and minus on here, that's always lovely. I like to put the values up if I can. I just want to make sure it's nice and tight to the board. And yeah, I'm using leaded solder on this because that's what was originally used. So that's this one, except for putting this repair switch on. And this actually is still a bit delicate, so I need to be cautious with it. But it's looking good. So I've got it just leaning on something on the that side, just so that it doesn't put all of its weight on the new switch, which has only been like 10-15 minutes, so I'm not sure that it has fully cured. What I'm going to do is just tack 2 positions on the switch in place, double check it's going on straight. Yeah, I'm happy with that. And by the way, there's your first look at those new switches in place. Yeah, slightly longer aluminium shank because it goes all the way down to the switch mechanism instead of stopping a bit early. Not identical, but near enough identical. So the rest of these joined up. That looks pretty good. I'm going to clean that up. So I've finished with this board. I've basically cleaned it. I've got 2 capacitors fitted. The new switch put in place. Well, new switch, the old reconditioned switch put in place. I'm going to squirt a little bit of switch clean into each of these and just work them backwards and forwards a few times before the final assembly. But yeah, it looks very good indeed. I'm really pleased with the way that's come out. Has to do on this board as well, just here, 4.7 microfarads. And there we have it. Second board finished. So I just need to leave this overnight to let that epoxy resin set properly, and then it can all be reassembled. Okay, so we're all cleaned up. The new switch has been fitted. Seems to work just great. The only problem with the switch is it looks so much cleaner than the old ones, but I have given the old ones a clean. I suspect that at some point someone's had some kind of household cleaner on them or something like that, and it's stained the top end, but I'm not going to try and replicate that on mine, of course. So punch these out using a round metal tube and a metal square thing, but because these are quite resilient, I haven't necessarily gone all the way through. So I'm just going to use a scalpel and just tidy them a little bit. These are just so you can't really see what's going on in the switches, and also just protects them a little bit from dust. So we don't see the metal glinting up from underneath. Right, okay, that's done. I'm just taking my time about this because I want to be sure that I don't accidentally slip up. It's just because I'm here to do a similar thing, just to hide the visibility of the insides of this. These two here are used from underneath the plastic. About there, time to put the top on and double check and make sure everything works. So So that's it, looking good. Need to get a little brush in there just to finish off the cleaning, but I don't have one in the lab at the moment. The next job then, so this should have multiple games. So that looks super great. So I think we've got the screenshots that we need to demonstrate that it's working properly, and I can now just ship this back to its owner, and fingers crossed someone will be happy with it for many years to come. Anyway, hope you enjoyed that. If you did, don't forget to give it a thumbs up, subscribe if you haven't already done so, share it with your friends, comment, all that jazz, and I'll see you next time. Bye for now.